Hello and welcome to this video in which we'll be looking at metals, non-metals and metallic bonding. Now let's just go back for a second, think about metals and where they are in the periodic table. Well, can you see this zigzag line here? This denotes the partition between metals and non-metals. So every element to the left of the zigzag line here is in fact a metal, which means if you count them up, of the 118 elements in the periodic table, 91 are metals. And the great thing about metals is we can define them by their properties. In fact, we'll look at 11 properties about metals. Firstly, all metals conduct electricity. Electric current is a flow of charge around a circuit. Now metals contain free electrons, and it's these electrons that can carry the charge. And because they conduct electricity well, metals are often used to make wires and parts of electrical circuits. Copper and gold are good examples of metals used in this way. Now in the house, in my house example, the wires are made of copper because it's relatively cheap. But if you want something really reliable, like in a spacecraft, you'd use gold. But it's much more expensive, so it's a bit restricted. Secondly, metals conduct heat, if you like, thermal energy. Energy is transferred through metals from hot areas to cold areas quickly and easily. And here we see energy transfer going from left to right. Now hot particles vibrate strongly, and these vibrations are passed to other particles we see here within the metal, which also start to vibrate, and so energy is passed from hot parts to cold parts, which is why saucepans are made of good conductors such as aluminium. Thirdly, metals are strong and tough. Metals are said to have a high tensile strength, which means they do not break when pulled hard. There are strong bonds holding metal atoms together, which is why we use metals where a lot of strength is needed, for bridges and tall buildings, for example. Fourthly, metals are shiny when polished. It's an amazing engine here, but that hasn't seen many miles. Now when polished or freshly cut, metals give strong reflection. You can see here the reflections off the engine from this smooth surface. And this saxophone, again, very shiny. Fifth, metals are, this is perhaps a new word to you, sonorous. Now sonorous means that metals make a ringing sound when they are struck, which is why they're jolly useful to make bells. And also you can use them to make gongs as well, wherever you need something to make a sonorous or ringing sound. Another new word perhaps, metals are malleable. Now malleable means the metals can be easily bent to shape, like these wheel arches here, or the bonnet, the roofs, they can be bent to shape. Malleable means the metals can be easily shaped because atoms in metal can slide over each other, and they can be hammered into thin sheets or bent, such as in these car bodies, all without shattering. 7. Metals are ductile, new word. Ductile means that metals can be drawn into long and very thin wires. Unlike non-metals, they just bend and stretch. They're not brittle, they won't snap. Metals have high melting and boiling points. Some figures, look at these melting and boiling points down here. So tungsten doesn't melt to over 3,400 degrees Celsius. That is hot. So atoms in metals are joined together with very strong bonds, and a lot of energy is needed to break them apart, to melt and boil. Metals, as this guy is finding out, have high densities. Now by definition, a density is a measure of how much stuff is squeezed into a certain space, which is why metals feel very heavy, and I think this guy is wishing they didn't. For their size, because they have lots of atoms packed in a relatively small space, they are very dense and they are hard to lift. I wonder if he's learned his lesson now. Number 10, metals make alloys when mixed with other metals. Now an alloy is formed when different metals are combined together. The properties of alloys are different when compared with constituent metals. So this wheel here of a car, this is an alloy, and the metals are being combined to make it shiny but also very strong. So this means that light and strong alloy, such as car wheels, can be made by combining light, weak metal, which may be very shiny, with a heavier, stronger metal that gives it the strength. Best of both worlds, alloys are good things. And the last property of metal is that some metals, not all, are magnetic. Iron, nickel and cobalt are examples of magnetic metals, and alloys of these metals will also be magnetic. Steel, which is an alloy of iron, is also magnetic. So there we have the 11 properties of metals. Let's look now at their keywords. So here's some keywords. First keyword, density. Now density is a measure of compactness and its ratio of mass to volume, and metal, the shiny element, is a good conductor of electricity and heat. It's always good to have a couple of definitions up your sleeve. You never know when you might need them. Right, let's revert now to non-metals. Now, if all these over here, okay, are metals, it means everything to the right, the zigzag line there, is a non-metal. And that's not a lot. In fact, we can actually name all the non-metals in the periodic table. Helium, hydrogen, carbon, nitrogen, oxygen, fluorine, neon, phosphorus, sulfur, chlorine, argon, selenium, bromine, krypton, iodine, xenon, radon. Phew. Not many though. In fact, we've got 8 properties here of non-metals. Firstly, they're pretty poor conductors of electricity. Non-metals do not have free electrons, so current cannot flow through them. This means that non-metals can be used as electrical insulators to make things like plug and cable coverings. Okay. Non-metals are also poor conductors of heat energy. Because of their molecular structure, non-metals do not transfer energy from hot place to cold place very easily or quickly. This means that non-metals are really good insulators and the particles do not pass on vibrations well. So, for example, this loft insulation here is made of non-metallic material. It keeps the heat in, we hope. Thirdly, non-metals are not strong or hard wearing. In fact, they're very brittle. Non-metals break easily because the forces between particles are weak. It's easy to scrub atoms and molecules off them, so it's really useful for things like pencils. So when you're using a pencil, the middle bit here is called graphite. So when you're writing, you're rubbing off layers of graphite. Fourthly, non-metals are dull. This doesn't mean they're not very interesting, it means they're not very shiny. The surfaces of non-metals are not usually as smooth as metals. This means that most non-metals do not reflect light very well at all, and this makes them look or appear dull. The one exceptional exception is diamond, which is a form of carbon, which is incredibly shiny. Non-metals are brittle, and thankfully for this guy they are. Weak forces hold together non-metal structures, like these blocks here, which means they can shatter very easily. Without steel reinforcement, concrete is actually very weak. So these blocks are inherently very weak unless you put some steel reinforcement in there, easy to break, as this guy here shows. But, to be honest with you, I wouldn't want to try it. I'd probably break my hand before I broke the blocks. 6. Non-metals have low melting and boiling points. Non-metals melt and boil very easily. This is because the forces holding particles together are very weak. So the forces between particles are very weak. Most non-metals are gases or solids at room temperature. Wow, look at this then. That should be, I think most non-metals are gases or liquids. I think it should be liquids there really, personally. So look at these. So oxygen, melting point minus 218 degrees Celsius. Boiling point minus 183. Wow, that is cold. Very, very cold. Non-metals have low densities. Most non-metals have relatively few particles packed into a given space. This means they do not feel very heavy. Right, got it. So non-metal gases have very low densities and will float in air. Even liquid and solid non-metals have low densities. This fantastic, wonderful Ferrari racing car, Formula 1 over here, is actually made of carbon, a non-metal. Carbon graphite, be right, and it's very, very strong, as the drivers are very happy about. Lastly, non-metals are not magnetic. Sulfur is a non-metal, so it's not attracted to magnet. So if you've got a mixture of iron filings and sulfur, you can easily separate them with a magnet. The iron filings will be attracted towards the magnet, sulfur will not. Now, keywords here for non-metals. Brittle means that is easily broken. And an insulator is a material that does not allow charge or heat to pass through easily. 2 more keywords there for your vocabulary book. what is really useful is to have a comparative table. Now in this one here we're comparing the properties of metals and non-metals. I'm not going to read through it all, but you can see the properties include conduct electricity, metals are good, non-metals are poor. Conduct heat energy, metals are good, and so on. Okay, and it comes right down here to magnetic materials. Only iron, cobalt and nickel are magnetic, no non-metals are magnetic. So it's a really useful table here to learn, to revise, so you can compare metals and non-metal properties. Great. Lastly, we've got to finish off a bit here on metallic bonding. We've looked in other videos at covalent and ionic bonding. Another sort of bonding is metallic bonding. Now, like ionic and covalent, they consist of giant structures. Now, electrons, the outer shell of metal atoms, are delocalized. This is a really important word, delocalized. It means that these electrons here have no definite place. They are free to move. Nice one. So that's delocalized electrons. Remember that? We haven't got a vocab sheet here for this section, but worth putting down. Delocalized means free to move about. There are strong electrostatic forces of attraction between the positive metal ions and the shared negative electrons. These forces of attraction hold atoms together in regular structure called metallic bonding, which is very, very strong. And compounds held together by metallic bonding include metallic elements and also alloys. So I hope you understand now what's meant by the term metallic bonding. And that's the end of this video on metals, non-metals and metallic bonding. Thank you ever so much for watching, and I'll be back with another video very soon. So bye bye for now.